Let's consider another case study. The problem report says that the internet is not working. Wow, that's a big deal. That's probably not the actual cause or not the actual symptom. We want to clearly define the problem and see what's going on. So we try to understand what is the user trying to do. And they're trying to go out to some website and they're not able to get to that website. So we try to verify the problem the best we can. And we start to gather some information. We notice that from our computer, not the user's computer, but from our computer, maybe in a different office, in a different building, we're able to get to Cisco.com. Whew, deep sigh of relief, the internet is not broken. And we notice that the user has a laptop, and I've seen this several times. Many laptops have a little a very small switch that's hard to find sometimes that will enable or disable wireless access on that laptop. And maybe the user's laptop has the wireless card turned off. Well, in this case, we check, no, it's turned on, and we start to follow the path. Can this user's laptop get to their default gateway? We ping the default gateway. Yes, we can. We know the IP address of an internal server. Can we ping that? Yes, we can. Can we ping a DNS server that we know about? Yes, we can. Why is this not working? We try a few other sites on the internet. People used to come to me and complain all the time that a specific site on the internet was not accessible. And I had to explain to them, I don't run the internet. You can get to all these other places on the internet just because this sports site you're trying to reach doesn't work. Really not under my umbrella of responsibility. But here, we're not able to get to any internet site from this user's laptop. And we try something. We try to do name resolution of Cisco.com. We could get to it from our computer. We know Cisco.com is up, but we're not able to resolve the name from this user's computer. Suddenly we start to think about DNS issues. And we take a look at the user's DNS address, and we compare that to what's in the documentation. The documentation says that the last octet should end in or should be a 6, but we take a look at the user's PC, and it should be a 5. Uh-oh, we've got an inconsistency here, and we hypothesize what we think might be going on. It might be that this, and this would probably be my guess, first off, I would guess that the DNS server was statically configured on this user's PC, and it was statically configured wrong. So we go check. We go into the network control panel, and ooh, look at this. It says we're automatically obtaining the DNS server information. Well, that's not, our hypothesis was incorrect. All right, let's go back and let's gather some more information. Now our hypothesis is, well, I'm getting incorrect information, therefore, the DHCP configuration that's giving me this DNS information, it must be incorrect. So let's go check that out. Before we do that, though, we're double checking to make sure that this PC will get out to the internet. If it uses the correct DNS IP address, we change it to a 6. We do it manually. What do you know? We're able to get it to Cisco.com. We're able to get out to the internet. This further leads us to believe that we have a misconfiguration in our DHCP server, so we go check it out. Now, we can have a variety of servers acting as our DHCP server. We can have a Microsoft Windows server. Here, we're using, looks like we're using router R3 as a DHCP server. Cisco routers do a fabulous job of being DHCP servers. And look at this. There's a DNS server configuration in R3. Ooh, and it's pointing to the wrong IP address for a DNS server. It ends in a .5. It should end in a .6. We fix it. We change it. And we copy our running config to the startup config. And maybe we document that while we're at it. We go back, and sure enough, from our computer, we're now able to get out to the internet.